A surface wave is a 90-degree wave that propagates along the interface between different media, or medium, which in this case are the surface of something, like water or the ground of the earth. Love waves, or L waves, are horizontally polarized waves, which you can see they are horizontal since they are moving on the horizontal line and not vertically. These are the waves I will be focusing on, since these kind of waves are the result of impacts on the surface. Mediums are really important for this subject, since it is not only where the wave travels through, it is also the point of impact that causes the wave. An example of this are the Earth and Moon. To simulate this, I will use this sand to simulate the Moon and this sand to simulate the Earth. This will be the meteorites, and the craters will be different since the first sand simulates low gravity, which the Moon has. This is the first sand, which simulates the Earth. The craters are not very visible and have very little shape. This second sand simulates the Moon and its low gravity. Here we can very clearly see the craters, and they have a specific shape. This is how we can visually see how waves change depending on how the mediums are. The more dense the medium is, the wave will travel less since there's more particles it has to go through. Amplitude in waves are the distance between the crest and the medium line, which are a measure of the wave's energy. With this equation, we can find the wave's energy in joules, which is E equals hc over wavelength. In this case, E equals energy, h equals Planck's constant, c equals the speed of light, and that symbol equals wavelength. If you're wondering, this is Planck's constant. Seismology and this subject are both very related since we can use the same tools or ideas as seismology. The difference between these are the fact that the impact waves are caused on the surface and not below ground. Because of this, the focus and epicenter in impact waves are the same since it is in the surface, while in seismology the focus is below the epicenter and the epicenter is on the surface. For this next experiment, I will be using this pair of headphones as a seismograph. The microphone attached to the headphones will be underground, and I will hit the ground with this hammer to cause a wave, an impact wave. The microphone will be measuring sounds in decibels, and the only sound that will be able to reach the microphone underground is the sound from the wave. I will do this in two different mediums, grass and cement. This will help us determine how much energy is caused depending on which medium we hit the ground in. These are the results for the first attempt in the grass. These are the results for the cement. You can see that it is lower. This proves the fact that the less particles there are, or the less dense the medium is, the wave will have more energy and will travel longer. To finalize impact waves, we learned how important mediums are, since the waves depend on what the medium is or how dense it is. Also, we saw how people can use tools to measure and understand these waves.